A particle of mass m is projected with a velocity v making an angle of 30 degrees with the horizontal. The magnitude of angular momentum of the projectile about the point of projection when the particle is at its maximum height h is to be calculated. So let us say this is a point of projection, and when the particle is at its maximum height, this vector represents its position vector and this vector represents its velocity vector. The velocity vector would definitely be horizontal at the maximum height of the projectile. So let us say this has a magnitude of r and this has a magnitude of u. What is the angular momentum? Angular momentum is defined as, say, L vector is equal to the mass times r vector cross product with u vector, and this r cross u can be said to be the area of the parallelogram whose sides are r vector and u vector. So if we complete this parallelogram, what is the area of this parallelogram? It would simply be u times the height, which is this height. And this is the same as the maximum height attained by the projectile. So let us call this h. Angular momentum magnitude would be equal to the mass times the horizontal velocity of the projectile times the maximum height h reached by the projectile. So what is the horizontal velocity? The horizontal velocity is v cos theta or v cos 30 degrees. This has been the initial horizontal velocity of the projectile and it faces no forces in the horizontal direction. The maximum height h can be given by what is the difference of kinetic energy at that point of projection and at the maximum height. We have 1 by 2 mv square is a kinetic energy when it is just projected, and 1 by 2 mv square cos square 30 degrees is a kinetic energy at the maximum height. This difference in kinetic energy would be equal to the potential energy gained by the projectile. So m cancels out. We have v square sine square 30 degrees is equal to 2gh. So v square by 4 is equal to 2gh, or h is equal to v square by 8g. So multiplying this with the mass and the horizontal velocity, we get angular momentum is equal to the mass into v cos 30 is root 3 by 2 into v square by g. So this is root 3 or by 8g here. So root 3 by 16 into mv cube by g, which matches with option D. Hence option D is the answer.